Sapya,
Yes.
tell me the reactivity series.
Yeah, it's
Hmm?
potassium, sodium, calcium,
Hmm.
magnesium.
Then
I don't know after that. And then it's carbon,
carbon,
zinc,
aluminium, zinc, iron.
aluminium, zinc, iron,
Yeah.
uh, tin.
No.
No,
First you check, okay? And then tell me. Now tell me the activity series. Okay, so let's start. First, we will discuss some of the difference between the metals and non-metals. Okay, let me write it here. Okay, so here your metals and your non-metals. So the main difference between these two is that in metals they have 1, 2, and 3 electron in the outermost shell. In the outermost shell is also known as what? Valence valence shell, right? So in metal they have what? 1, 2, 3 electron in the outermost shell. And what about this non-metal? Non-metal will have 4, 5, 6, 6 and 7 electron in the outermost shell. I'm writing only OS. Okay, so what is the example of Na? What is the example of metals? If we will check this sodium. Sodium is having atomic mass 11. And if we'll write electronic configuration of sodium, it will be 2, 8, and 1. So in the last orbit, in the last shell, it's coming 1. So here if we'll check that, okay, one electron is there in the outermost shell. So this is what? Sodium is what? Metal only. If we'll check for magnesium, magnesium is how much? 12. So it will be 2, 8, 2. So here also in the outermost, it is 2. If we'll check for aluminium, it is 13. So in the outermost, it will be 2, 8, and 3. So all these 1, 2, 3 will denote what? That they are metals. And what about here non-metals? Let's say if I'm writing carbon. Carbon is how much? 6. So it will be 2 and 4. So in the outermost shell, it will be 4. And here also it is 4. And what about nitrogen? Nitrogen is 7. So 2 and 5. 5. What about oxygen? It's 2 and 6. So in the outermost, it will be 6 only. And what about sulfur? Sulfur is how much? 16. So it will be 2, 8, and 6. So in the outermost, it is 6. So in the outermost, if it is having 1, 2, and 3, so it will denote that it is metal. And if in the outermost, it will be 4, 5, 6, 7, then it will denote that it is a non-metal. Okay. And the and the very main point is atomicity. Okay, we'll discuss atomicity. What is atomicity? Like in this non-metals, in this non-metal, we always write Cl2, we always write N2 or O2. We never write Cl, no? We never write O, right? So here in this non-metal, it exists in a form of two atoms. Hai na? Existing in a form of what? How many atoms? Two or more than two atoms. So this two atoms will refer that it is a diatomic. It will never be N, it will never be O. It's having two atoms here. So it will refer that it is a diatomic. And what about ozone? Ozone is O3. So it will be triatomic. It will be triatomic. And what about your phosphorus? It is P4. So it will be tetra. Tetra means 4, tri means 3. Tetraatomic. So the atomicity of non-metals is always more than 1. It means it is always polyatomic. Polyatomic is what? Poly means which is more than 1. So, but here the exceptions are noble gas. Exceptions are noble gas. Because noble gas is what? Your helium, your neon, your argon, krypton, all are having one atom only. Okay, this is the exception. And this non-metal thing, all the um, except that monoatomic, the di, tetra, tri, everything is there in this non-metal, because we'll never write N, we'll write always N2O2. It's in a compound, है ना? More than one atom is there, more than one atom exists. But here if we'll but here in this metal one, we can write Na, we can write Al. It's not like you will write Na2, we'll write Mg3. No, we will write Na, we will write Al. So in metals, it will be monoatomic. Atomicity of metal is monoatomic, but the atomicity of non-metal is dia, tri, tetra means more than one. Okay, and here if we'll say, if we'll check that, okay, in the last orbit, the in the last shell, the your electrons are 1, 2, or 3, then we'll say it is a metal. If it is more than 3, then it will be a non-metal. Atomicity also, here in the metal one, it is always mono, means only one atom, and here in this it is poly. So next here. Okay, your metal and non-metal. One more main difference is your nature of oxide. Your nature of oxide. And this, let's take Na. Na is a metal. Na plus and O2 minus. In oxide, we'll take O na. Okay. So in Na plus and O2 minus, it will form what? It will form Na2O. Your magnesium is also metal. So Mg2 and O2 minus, it will be MgO. K plus 1 and plus O2 minus, it will be K2O. So all are what? All are basic in nature. That day also we discussed this part, that metal always is basic, basic in nature. All are basic in nature. Okay, but here in this non-metal, all are acidic in nature. Let's take nitrogen. If it will combine with O2, it will form NO2. C, if it will combine with O2, it will form CO2. So all are what? Acidic in nature. But here in this non-metal, some exceptions are there. Exceptions are exceptions are neutral, means not acidic nor basic. Example, H2O, your CO, your NO. NO means oxide of nitrogen. CO means oxide of carbon. And H2O is water, oxide of nitrogen. Or we can write N2O also. So these are what? Metals are always acidic in nature, sorry, basic in nature, and non-metals are always acidic in nature. But in non-metals, there are some exceptions which are neutrals, means they are not acidic as well as they are not basic. So these are the examples of the exceptions. Okay, here also there are some exceptions. Exceptions in metals. Okay, exceptions are some metals are acidic also. Metals acidic, which are CrO3, your Mn2O7. These are what? These are acidic in nature. But all other are basic in nature. Only these two are the exceptions. And one more thing that is important is metal oxide, which is amphoteric. That day also we discussed this word, hai na? Amphoteric means which are both basic as well as acidic. Like for example, your aluminium, your lead, your zinc oxide, all are what? All are amphoteric, means they are basic as well as they are acidic. And what are the exceptions here in the non-metals? Here some of the exceptions are, these are only the exceptions here. Okay, so in metals, the nature of metal is what? It is basic. Non-metal nature is what? Acidic. But in metal, there are some exceptions which are acidic also. For example, these two. And what is your amphoteric? Amphoteric means which are basic as well as acidic. These three are the examples of this amphoteric one. And in the non-metals, the nature of non-metal is that they are acidic in nature. And what are the exceptions? Exceptions are neutral. Means they will, neutral means not acidic nor basic. So these four examples are the exceptions of non-metal. Okay, understood?
Yes, ma'am.
Here, aluminium oxide means Al2O3, zinc oxide means ZNO. And what about your lead oxide? Lead oxide is PbO. Okay. So the three things we discussed right now is what? First is about your outermost shell, means 1, 2, 3. If it will be there, then you will consider it as metal. If more than 3, you will consider it as non-metal. Second one is atomicity. Your metals are always monoatomic in nature, but your non-metals are more than 1, means you can say polyatomic in nature. And what about the third point? Third point is that the nature of metal is always basic, but some are the exceptions here. And also the amphoteric means which is both basic and both acidic in nature. And your non-metals are always acidic in nature. The some exceptions are neutrals, means not basic, not acidic, as well as not basic. Okay, so now I'll explain this. Okay, so here is what: please stop calling me a careless zebra. Instead, try learning how copper saves coal. So potassium. Okay, let me write it first. Here I'll write. First is what? Your K, your Na, Ca, Mg, aluminium, zinc, Fe, Pb, H, Cu, Hg, Ag, Au, P, Au, and last one is Pt. So this is the reactivity series. Now we will discuss what happens when metal react with water. First question. Okay, what will happen? What happen when metal react with water? Okay, this is the first question, important question. So first we will learn about this potassium, sodium, and calcium. See, the these two your sodium, sorry, your potassium, sodium, and calcium, these three are most reactive, and they are most reactive, so they will react with cold water also. No need of hot water. They will react with cold water. They are most reactive. They will react with cold water. So if they will react with cold water, then what will happen? Then your first I'm discussing these two. Okay, your sodium and your sorry potassium and sodium. These are what most reactive. They will they react with cold water, and if they will react with cold water, then what will happen? Your potassium or sodium will float. Okay, these two will float in water. So if these two will float in water, then what will be the chemical reaction? Chemical reaction will be for potassium, it will be K plus water. It will be KOH, means potassium hydroxide plus H2 gas evolve. Okay, this is what? This is your hydroxide, potassium hydroxide, and your H2 gas will evolve. And what about your sodium? Sodium plus H2O will be NaOH and your H2 gas. So these two sodium and your calcium, potassium and sodium, these are what? These are very violent reaction here. Very violent reaction. What do you mean by very violent reaction? It means exothermic reaction. And what is the meaning of exothermic? Exothermic reaction means where large amount of heat is evolved. Large amount of heat evolved. Okay, now see, if let's say this is my beaker. Okay, here is your KOH and H2. Okay, this reaction, if let's say I'm taking KOH and H2, your H2 is what? H2 is hydrogen, so it will evolve, right? H2 rises upward. So what will happen when H2 rises upwards? Then in your atmosphere, what is present? Your oxygen is present. Oxygen is present, and what will happen? And if H2 and oxygen will react, then what will happen? It burns due to large amount of heat. Due to large amount of heat. Why? Because oxygen is best for burning anything, right? Anna, oxygen is best for burning anything. So if here your potassium and H2 is there, so H2 is what? It's a gas. So obviously it will move upward. So if it will move upward in your environment, the oxygen is present. So it will what? It will collide with your oxygen, and what will happen? The large amount of heat will obviously large amount of heat will evolve. So here what will happen? Your potassium or sodium also catches fire. And for sodium it will be in a color of this flame, the purple color, and for your sodium it will be somewhat golden yellow flame. Golden yellow flame. Okay, so now see here, these two are what? Your potassium and your sodium are most reactive. Okay, they are most reactive. That's why they will react with cold water. So if the elements are most reactive, they need what? They need hot water or they need steam to react. But these two are very highly reactive that they can easily react with your cold water also. So if they will react with cold water, then what will happen? They will float in water. Now, if they will float in water, then we will write some chemical equation. So for potassium, it will be what? KOH and H2. H2 is what? Gas. And for sodium, it will be same sodium hydroxide, and your gas will evolve. So here, if let's say I'm taking one beaker and I'm putting this K plus O2, K plus H2 reaction. So your H2 gas will move upward, है ना? Because it is what? It is a gas, so it will obviously move upward. So when it will move upward in your environment, there is oxygen, and oxygen is best for burning something. So if it will move upward, then what will happen? These two will collide. Your hydrogen and oxygen will collide. So it will give heat, large amount of heat, है ना? It burns due to large amount of heat. So if it will burns due to more a large amount of heat, then some heat, some fire also catches these two. Your potassium and sodium also catches fire because the heat is very much. They are what? They are very violent reaction. Very violent means they are exothermic reaction. And what is exothermic? That large amount of heat will evolve. So if large amount of heat is evolving, so obviously your potassium and sodium will also catch fire. So if they will catch fire, they will turn into lilac flame, which is in purple in color, and your sodium will turn into golden yellow flame. Okay, so these two understood about your potassium and sodium. Any doubt here? So,
No, ma'am.
okay, so now let's discuss about calcium. Let me write it. Okay, let me write it here only. See, for this, okay, your calcium. So calcium is also reactive, but it is not as violent as these two. So not so violent, not so violent. It will react with cold water only, but it will not catch fire. No fire. Okay. So the reaction is what? It is not so violent means not so much, yeah, not large amount of heat will evolve. So here no fire catches, है ना? So the reaction will be calcium plus water. It will be CaOH twice, and your H2 gas will evolve. So here what will happen? See, in these two, they are what? They are floating. Your potassium and sodium will float in water. But in calcium, it will not float. It will sink. Okay, do not float. Do not float. It sinks. Now what will happen? See, here in my beaker, let's say I'm taking this only, the calcium plus H2O, then what will happen? Your H2 gas will evolve. So if you here your H2 rises upward in the form of bubbles, है ना? H2 rises upward in the form of what? Bubbles. So, so if it will move upward in the form of bubbles, then some amount of calcium also sticks to it, right? Some amount of calcium also sticks to it. So it means like it will not float, it will sink. Why it will sink? Because some amount of calcium also sticks to it. Sticks to whom? This H2. Okay, so in this calcium one, it is what? It is not so violent. It is not exothermic reaction. It will react with this cold water only, but no fire will happen. See here, no fire is catching with this H2. So obviously, if no fire, then if no more heat, then no more fire, right? So it will not float, it will sink. If H2 will evolve, then what will happen? Some amount of calcium will sticks to it. So it means if something is sticking to something, then it is not, then what will happen? Okay, so here what will happen? Your Ca will stick to it, so it will also float. Now you understood about this Ca also, calcium also done. These two are highly reactive, they will react with cold water. Your calcium also react with cold water, but these two will float in water. This will not float in water. Here the reaction is very exothermic, but here the reaction is not exothermic. It will not catch fire. In these two, it will catch fire. If it will catch fire, then what will happen? Then some amount of sodium and potassium and sodium also catches fire. So this will turn into these type of flames, but here they will not catch fire. So here they will not turn it into some kind of flame. Okay, understood? This is highly reactive, but this is not that much reactive. Now, next is what? Next we will talk about the and one more point about these three means your let me write here. One more point about these three, your K, Na, and Ca is that they. Oh my God! Just a second. Yes. So one more point about these three, that they are what? They are basic in nature. Okay, turns red litmus into to blue. They are what? Basic in nature. These three are most reactive. Okay, understood, Sophia? Now next we will talk about these three are done now. So later on we'll discuss about this, but this aluminium, zinc, and Fe. Aluminium, zinc, and your iron. So these three are very less reactive. Very less reactive. It reacts with what? It reacts with what? See, these four are reacting. These three are reacting with very cold water. So this aluminium will react with steam. Okay, it will reacts with steam. Now, if it will react with steam, then what will be the chemical equation for Al? It will be for H2O, Al2O3 plus H2. For your zinc plus H2O, it will be ZNO plus H2. And for about your this iron, it will be H2O giving Fe3O4 plus H2. But one main thing about iron is that it is reversible reaction. It is what? It is reversible reaction. It is reversible reaction. Okay, and here ZNO yellow when hot and white when cold. So if we will react this ZNO with hot water, it will turn into yellow, and if we will react this ZNO with cold water, it will turn into white. This is the property of zinc oxide. Now, let's talk about this Mg. Mg is what? See the here is what your this three are also done aluminium, zinc, and Mg. Mg needs not steam nor cold water to react. Not steam nor cold water to react. It needs what? Hot water. Okay? Hot water means Mg plus H2O will give you MgOH twice plus H2. And what about these? So this also done. And what about these? So these are what? These are your noble gas. They don't react with either hot nor cold, and not even your with cold water. Okay, all your PBH, CU, HG, AG, AUPT, AUPT, they don't react. They don't react with either hot, steam, or cold water. Okay. So now we will discuss once again. Okay. So what about these two? Your potassium and sodium. Now, Safia, you will explain me. What about these two?
Yes, ma'am.
Explain me about this potassium and sodium. Tell me at least some one two
Potassium
points.
and sodium are they're very reactive
Hmm.
and they react vigorously.
Yeah. Then don't know.
No, no.
Okay. So here sodium and potassium and whatever, potassium and sodium, these are what? These are most reactive. They react with cold water. If they will react with cold water, what will happen? They will float in water. And what is the chemical reaction? If we'll combine the potassium with this water, will get what? We'll get potassium hydroxide and H2 gas, and here sodium hydroxide and H2 gas. So if you are taking one beaker and if you are putting the potassium hydroxide and some H2 gas, then what will happen? H2 is a gas, so obviously they'll move forward. Sorry, and obviously they'll rise upward. So if this H2 will rise upward, then what will happen in your environment? The oxygen is present. Oxygen is best for burning, right? So H2O will combine with oxygen, and if H2 will combine with oxygen, then what will happen? Large amount of heat will evolve. Okay, if large amount of heat will evolve, then what will happen? Some amount of your potassium and sodium also catches fire. So if these two catches fire, then what will happen? This will turn into some purple flame, and the sodium will turn into some golden yellow flame. Okay, most reactive react with cold water. If they will react with cold water, they will float. This is their chemical reaction. And if they are what? Very violent means they are all they these are known as what? Exothermic reaction. And what is exothermic? Exothermic means where large amount of heat is produced. So here if H2 will move upward, then oxygen is there, and if H2 will combine with oxygen, then large amount of heat will develop. If large amount of heat will develop, then some amount of your potassium and sodium also catches fire, and if these two will catch fire, then they will turn into some different colors of flame. Okay, now understood?
Yes, ma'am.
Okay, now explain at least 1 2 point.
Ma'am, when they react, the reactions are very exothermic and a large amount of heat is produced.
Mhm.
And when they are burned, they turn into flames of different colors. Like potassium turns into lilac flame, and sodium produces a yellow flame.
Yes. Next is your calcium. Calcium is what? Calcium is not so violent. Okay, it also needs cold water, but it is not so violent, and it will also not catch any fire. So this is the chemical reaction. And what will happen if some see, if here this is your what, this is your calcium hydroxide, and some H2 gas is evolving, it's rising upwards. So what will happen, some amount of calcium also sticks with it. So this will, so what will happen, your calcium also, some amount of calcium also float, and some amount of calcium also sinks. Okay, if some calcium is sticking, then what will happen, obviously it will float, and if it's not, then it will sink. So this is the simple one. Now what is the next? Next is your magnesium. Where's your magnesium? Huh. Magnesium needs not cold water, not even your hot water. Sorry, not even your steam. It needs hot water. And if it needs hot water, this is your chemical reaction. Next is these your, and one more point of this potassium sodium is what? That it is basic in nature. It turns red litmus into blue. And here your aluminium, zinc, and iron, these are what? These are less reactive. If they are less reactive, they react with steam. That potassium and calcium was what? Highly reactive. So they are reacting with your cold water also. They can react with your cold water also. This is what? This is less reactive. So these are reacting with your steam. Not will react with your steam. So this is the reaction. But the important point of this iron is that it is also a reversible reaction. And your property of zinc oxide is what? If it will react with hot water, it will change it into yellow flame, and if it will react with cold water, it will change into white flame. Okay, and what about your noble gas? Sorry, what about these? So they don't react with either your hot water, not even your cold, and not even your steam. Okay, so any doubt?
No, ma'am.
Okay, so you have to learn this. Okay, it's easy only now. Please stop calling me a careless zebra. Instead, try learning how copper saves coal. And these are what? These are most reactive thing. These are less reactive. Okay, now next is that it's next we will discuss about that what happens when your metal react with acid. When metal react with acid. This we will learn in the next class. Okay. So order of reactivity, this we already did. Next is what? Next is your reaction of metal with water. Just now we discussed now ki how what happened when metal react with water. Here also see your metal plus water, metal oxide and hydrogen gas. Metal plus oxide plus water, it's metal hydroxide. For potassium, it is taking that, see, potassium and here cold water. Why potassium and cold water? Why for potassium it is taking cold water, Safia? Come on.
Because the reaction is very exothermic.
Yes, that's why it is taking cold water, and if it's take cold water, it will produce potassium hydroxide and hydrogen. For sodium also, the reaction is very exothermic. So sodium hydroxide and your hydrogen. Next is your calcium. Calcium also need cold water, not, but it is not very reactive. What about your see? This is what less violent. This is what highly violent. है ना? React violently with cold water. The heat evolved is not sufficient for the hydrogen to catch fire. Here, the heat is evolved is not sufficient for hydrogen to catch fire. But here, very large amount of heat is evolving. That's why your H2 catches, hydrogen catches fire. But here, your not sufficient amount of heat, hydrogen is getting to produce fire. Okay, and here what? Calcium floats over water because the bubbles of hydrogen sticks on the surface of the metal. Okay, and what about your aluminium, iron, and aluminium, zinc, and iron? These are what? These are less reactive, so they need steam. So aluminium oxide and ferrous oxide. And what about these? These do not react with water at all. Do not react with water at all means not even your cold, not even your steam, and not even your hot. Okay, so now what is next? This only we will next discuss in the next class, reaction of metal with acids. And now what is the next one? The reactivity series of metal. Okay, then understood now?
Yes, ma'am.
Okay. Okay, thank you. Bye.
Thank you, ma'am.